Tekrar merhaba. Evet, son oturumlarımız için yine birlikteyiz. Şimdi sözü daha fazla uzatmayacağım. Modus Create'den baş danışman Mesut Güneş'i sahneye davet edeceğim. Kendisi yazılım geliştirme süreçlerinin tüm yönlerini otomatikleştirme konusunda tutkulu bir uzman. Aynı zamanda da açık kaynak teknolojilerinin gönüllü bir savunucusu. Sayın Mesut Güneş'i sunumlarını yapmak üzere sahneye davet ediyorum.
Merhaba, sesim geliyor mu? Hello. So, welcome to Istanbul Software Testing Conference. Sorry, I need to get this one. Yeah. So, my presentation will be about continuous software testing, and the motto will be, performance is a live thing. So have you ever faced an issue that is on the live, related to performance, simultaneously with your real users? Maybe you can say yes, because in my early career, I faced this issue many times. This is because, in general understanding, the performance testing is at the end of the life cycle, but yeah, it shouldn't be in that way. So my name is Mesut Güneş, and I'm a father of 2 kids. You can see my squad at home having a lesson about how to keep the home clean. So, and this is a regular lesson that we are having in their home, since we don't learn how to keep the home clean. And you can scan the QR code to get my professional background. Basically, I'm a principal consultant at Modus Create. Modus Create is an US-based consultancy company, and we have clients mostly from the United States and from Europe. Those are kind of enterprise companies and also some startups. And you can find me in the internet with these nicks and IDs. So let's move on. So let me know who you are with asking some basic question. If you can raise your hand, who has the title of tester, QA, or STATS? Can you raise your hand? Yeah, good. And who has the title of developer? Do we have any developers here? Yeah, I see. That's also great. And who has the title specifically with the performance engineering or performance engineer? Do we have any performance engineer here? Good. Yeah, I see. So, have you ever done any performance testing in your career so far? Okay. Yeah, this is a good audience. So far, I'll talk about continuous performance testing, and the topic will be around this one. Basically, it is around performance testing and toolings and so on, what is needed for doing a continuous performance testing. This is a table of content. Basically, I'll talk about, firstly, what is performance testing, and then I'll create a connection between continuous performance testing and the performance testing. And the next 2 parts will be mostly how we can do the performance testing. So we need to define the metrics and also the tools and technologies that we need to while applying continuous performance testing. So at the end of the presentation, I'll talk about what kind of benefits we can get with the continuous performance testing. So basically, this is kind of long presentation, and so I need to move some part of the presentation faster. So if you can get notes about the things that you don't get and ask at the end of the session, that will be great. Let's start with the first section. It is, what is performance testing? So basically, the performance testing, we can, by the way, the slide is kind of has a problem because it most probably converted to Microsoft. Yeah, but by the way, it can be still understandable. So let's talk about the performance testing by the definition. So basically, performance testing is designed to test the performance of the application by applying some performance testing to get responses from your system and then analyze your system. So performance testing is basically non-functional thing, while we are trying to test the functionality of the system. And we can apply the performance testing at any level of the software development lifecycle. I mean, starting from the unit level, you can apply the performance testing. So within the two dimensions, the level of the software development, and also how to do the performance testing. In terms of those areas, we can define the performance testing activities as non-functional and the functional activities. So sometimes we need to deal with the internal structure of the overall system. So which means that you need to deal with some the coding activities, or let's say the architectural plan, or some design elements. So which means that this, in terms of this area, we can say that the performance testing is a white box testing. But while we are executing the performance testing, it is we are testing the black box stuff with sending a request and then testing the overall performance of the system. So it's kind of black box testing technique. So also we can understand the performance testing by defining three metrics, three dimensional. So the level of the load that we are using during the performance testing is the key factor, and then how we can increase the load during the performance testing is also another criteria, and also the duration. Those are three things that we should consider during the performance testing. And also we can define the performance testing by process. I mean, with the process, we should collect all the information from the client or from the users, and in the planning phase, and then we need to understand all the requirements, and then that will be an artifact for the creating the test scripts. After creating the test scripts, we need to create a test environment. The test environment should always be the same within the resources, CPU, memory, and other stuff, and the network. And then we can now start executing the performance testing. While executing the performance testing, it is critical to monitor the system, because, we have already defined a load, and then this load is going to the system. But if those are not correctly phasing with our system, then if we don't see those metrics on the monitoring system, then there should be something wrong on the system. So what we should do a quick fix and then run the performance testing again. So the last step of the performance testing is, in the meaning of the process, is the analyzing and optimizing the output. So this is kind of process that you can follow. And let's move on to different types of performance testing. As I said in the earlier page of the presentation, there are three criteria. The first one is the load. Load is the number of virtual users. The virtual user is the user that you are adding to the system while executing the test scripts, the performance scripts. And another important criteria is the increment of the load. So if we increase the load by step, or it can be suddenly increase, or it might be a smooth transition or linearly increasing the number of loads. So this is also important criteria. And the last criteria is the duration. If we are running the load testing in a minute or until all the user hatch on the system, or it might be prolonged time, let's say hours or days. So these are the criteria that we can name the performance testing. And let's start with the load testing. This is the first and well-known performance testing type. The load test is basically testing the behavior of the system under a nominal load. With the nominal, I mean the expected load that you can get the load on the live system, which means that this is an test to get the system responses when you go to the live. So this is a basic form of the performance testing, and when you are talking about performance testing, most of the people can get the idea of the load test because it is widely known and the basic form of the performance testing. And this is the load test is executed under an optimum load because we want to get the real responses of the system when the real user gets from these results from the real the real live environment. And the next one is the stress test. Basically, stress test is to test the upper boundary of the system, which means that we are increasing the load step by step until the system comes to a level that is the level of the system can carry out. After above this level, system stability can be broken, and then the response time can be easily increased. Or at that point, maybe you can get some 4 or 500 responses from the system. So this level is the stress level of the system. So until this point, we can execute the test script to get the upper boundary of the system. With this system, we can get how many user or how many load can our system carry. And then with this way, we can design an architectural system of our overall system. So, and also get the responses when the system is under the stress. So basically, what we need is we need more resources when we compare to the load testing because we need to add as many as user to the system to get the stress level of the system. And so we need to pay more attention because we are testing the boundary of the system. And just one user above, maybe system starts giving an unexpected result. So, and this is a type of testing that we can apply before going on promotion days, like Black Friday, 11/11, and so on. And so, or sometimes it is called endurance testing. So you can imagine that there is a stress level of the system, and if we can do the stress testing for a prolonged time, which means that the stress testing is continue for a long time. With the long time, you can define it days, maybe hours. So with this way, we can also test the promotion days, like Black Friday again, because when the Black Friday is kind of one-day promotion, so which means that you will get a lot of users during the day, which means that your system always be under stress at these days. So SOAK or endurance testing is an good practice for this one. So in the picture you see that Eliud Kipchoge, he broke the marathon runner under 2 hours. He could be able to manage this one by keeping his performance at the stress level of him, and then he can keep up this level for 2 hours. So he could be able to manage this marathon run under 2 hours. And there is also spike test. Spike test is good for an promotional activity. Let's say you are an e-commerce company, and your marketing team is sending a notification to all the mobile application, and then suddenly all the users are clicking the promotion button, and then your system getting a lot of loads because of this activity. Most of the cases, during the mobile application initiation, there are a lot of requests sent. So which means that your system will get a lot of users, but suddenly your load can decrease. So spike test is a simulation for such a scenario. This is kind of testing your system under a sudden increase of load, also sudden decrease of your load. So maybe your system can be scaled or can be broken. So this is a good test for understanding your system behavior. And the capacity test, as you can see from the images, capacity test is aiming to find the maximum amount of the user that your system can consume for maybe one server. So with the capacity, when a user added to your system, then it has a lot of data on the database. So your system should handle those information from the database. So with this capacity test, we can examine the reading and writing activity on the database. So the capacity test is testing the servers, the amount of the user that a server can get. The next one is also the volume testing. There is really relationship between volume test and capacity test. So you can imagine that maybe we can give an example, something like this. Turkish Airlines sends one flight, and then it has maybe 100 users. But if one more user can gain the system, then the Turkish Airlines should be reserved one more flight. So what we are doing here, we are just testing the scalability of the system. So during the capacity test, if we go beyond the capacity of the one server, then the next server can easily add it to system. So which means that we are testing the scalability of the system by the volume test. And this is an image that shows all type of the performance testing in one image. You can see that the amount of the user is very important criteria, and the duration, and also the strategy of the increasing the load of the system. Okay, let's talk about the continuous performance testing. I think I need to go faster. So the continuous performance testing, so far we explained the performance testing. And the continuous performance testing, doing the performance testing automatically, which means that in your CI and CD pipeline, you can run the performance testing automatically when there is a change on your system. So the continuous performance testing is part of your CI/CD pipeline, and with the continuous performance testing, we are doing the shift left testing because we are we are giving them feedback as early as possible with the performance of the system. But at the same time, also it is kind of shift right activity, because we are also monitoring the whole system and analyzing the performance of the whole system. So which means that we are always monitoring the performance of the system continuously. And we can also say that the performance testing is a perceptional activity, because, when a user, it is really depends on the user psychology. For example, when you are a good mode, waiting 1 second or even 2 seconds for page to be loaded is okay. But maybe you are in a rush, maybe you are not in a good mode, then waiting only 1 second is not a good thing. So it is a perceptional activity, so which means that we need to monitor the system continuously. Whenever there is an issue on the system, that we need to fix the last commit on the system. And so basically, we explained the types of the performance testing, and then how we can apply the performance, different type of the performance testing is also the key question. Basically, the load testing can be easily applied for the continuous performance testing, because there is a defined level of load. Also, there is a matrix that we can get from the earlier experience or some observation. So we can easily apply the load testing, but at the same time, the spike test or maybe stress test can also be applied, but it is kind of hard, because you need to observe maybe different level. So if there is an issue on the system, but SOC and Andrews test is very hard to apply. So basically, automated load testing is the testing the performance test automatically, which means that we need to create a pipeline that is running the performance testing at a specific level, and then it can evaluate the result of the performance testing, and then the evaluation should be smart enough to give a decision about go or not go activity. So when we automated the performance testing, it will be very easy to integrate your CI and CD pipeline. Okay, let's talk about the matrix. I have only 7 minutes. Let me go through the matrix. Basically, we have two kinds of matrix. The first one is the response, and the second one is the volume matrix. With the response, I mean, when you are sending a request to your system, then there will be a response from your system. So this response has a lot of information regarding the performance. It can be response time, and then some different type of the responses, like average response time, peak response time, maximum and minimum response time. Also, there's a wait time. It is between your sending request to getting a first byte from the system, and also the error rate. This is the response matrix. Also, there is volume matrix. The volume matrix is the how much user you are using while your performance testing, and the number of requests per second is another volume matrix, and maybe the third one is the throughput. It is the data that is in kilobyte, and your system or your servers can respond back. Okay, so this is really bad. So whatever. So let's talk about the response matrix. So basically, you can see an image from the K6. It is one of the famous and open source performance testing toolings. So the response time is the key matrix while you are evaluating your performance testing. And then, And then also, there is also the different variant of the performance response metrics, like the average, minimum, medium, and the peak of the responses that we can also use while evaluating the evaluating the result of the responses. Also, the volume metrics, as I said in the previous pages, the RPS, which is the request per second, is the key factor, which means that your system observing a number of requests each second. And then the concurrent user is the user that is on the system, and the RPS is the metrics that you are adding to your system. The hash rate is how many virtual users adding to your system in each second. And the throughput is the data that the system is returning. Let's talk about the statistics. Statistics is really important while evaluating the result of the performance testing. Since the performance testing creates a lot of data, we can use the normal distribution. The normal distribution is basically when you have good enough data, then your data behave a normal distribution. And you can see the images in the column on the middle. It is the average value, and within the two standard deviation of your system, it will be the 95 confidence level, which means that if we examine the system within the 95 confidence level, that means that we are covering all the responses from the system in 95 confidence level, and we can create a hypothesis on this. So maybe this is a hypothesis that every matrix is similar with the historical data within the 95 confidence level, which means that we are getting a response, and this response is similar to your historical data. That is the first one is just using the historical data, but this one is the static data when we are comparing the result. This is again an image from K6. So within the K6 capability, we can also define the 95 percentile or 90 percentile of the responses, and also some other metrics as it is defined in the table. So here I'm also using AI because I am lazy enough to calculate the 95 confidence level of my responses. You can see that I asked the AI to examine the hypothesis that if the return response is in the 95 percentile. And I'm also giving the detail about the historical data. And the hypothesis one is the current responses within the 95 confidence level, and the alternative one is it is not in the 95 confidence level. So it is calculating all the things and then comes as a solution, and it is saying that based on the 95 confidence level, the current test result can be considered passing because the responses is similar enough to the historical data. So you can create a method to also evaluate your result, but this is an AI equivalent of the evaluation. So let's talk about tools and technologies. I have only 1 minute or 2 minutes, let's say. Let's go through quickly from here. So when we are talking about the continuous performance testing, it is an application of the performance testing by means of automation, which means that everything is automated. So there is no human interface during the execution of the test, and then also evaluating the result of the performance testing, and also comparing and monitoring is another tool set. So basically, we need to have some kind of performance testing tooling, databases, reportings, toolings, and also comparison toolings like AI, all the orchestration toolings that all the things in the CI should be in a pipeline and run automatically, and also the monitoring system. Monitoring system is the evidence that everything comes up to system and the response is okay. And also there are some, this is basically the performance testing toolings. Let me quickly check it. The JMeter is one of the well-known, and then Gatling, K6, Locus. These are kind of open source tools, but there is also commercial tools like LoadRunner, BlazeMeter, LoadUI. You can pick any of them. And also we need to have an automation tool that should be run all the CI pipeline. Maybe it is Jenkins, Travis CI, or Circle CI, whatever, GitHub CI, GitHub Action. And orchestration. These tools are also needed to make your system more robust, and it can be executed at any time. Monitoring tools, similarly, we should implement some monitoring tools to our system to get everything is monitored and everything is visible to your system. And it can give an idea about overall system. And let's talk about the benefits. This is the last section. And so basically, continuous performance testing is a shift-left activity. So whenever there is a change on your system, there is a commit to your code base, as part of your CI/CD pipeline, continuous performance testing give a result of your system within the performance of the whole system, which means that if there is an awareness about the performance of every commit, that your developers will pay more attention on the performance of the commits, which means that if there is an issue with, let's say, the database, let's say the query, let's say the indexing, that your developers will pay more attention on this kind of stuff and then make your system robust. So, and then while the continuous performance testing, we are also keeping the historical data, which means that maybe you can return back to 1 month ago, and then you can check your system results, and then evaluate your trends on the system. Maybe your system is just small, maybe there is a small enough deviation on your system, and then it will be in 95 confidence level, but this kind of trend in a year can make your system very bad, which means that your system can behave beyond your design. So this should be also tracked by monitoring system, and this is kind of benefits of your applying continuous performance testing. And this should be the last. Yeah. And thank you for listening to me. And then you can connect me on LinkedIn with this QR code, and also you can download the presentation. And these are the references while I'm creating this presentation and doing the continuous performance testing on our clients. And yeah, thank you. If you have any question, I'm here to answer it. There is.
Test. Can you hear me well? Okay. Thank you for your presentation and this amazing content. You mentioned some increments while you are executing stress test. How we can determine these increments or these intervals while executing the stress tests?
Do you mean the upper boundary of the system, right?
No. I mean you show us something in graphic while you are executing stress tests. Some increments. There are some increments.
Yeah.
How we can define these increments, this interval? while executing stress tests?
Oh yeah. So basically, in the beginning of the stress testing, we don't know what is the upper boundary of the system, right? So what we can do, we can increase the load in a systematic way. Let's say start from the 100 user, and then maybe there will be a 10% of increment. Let's say it can increase the 110, and then it can execute, let's say, 2 minutes, and then we can check the whole responses from the system. If there is no deviation or the decrease on the responses, then we can increase again. So we can increase until your system get into the stress, which means that the response time can increase dramatically, or your system can be broken. So we can define the step by step by like this.
I see, thank you.
And there is also here.
Thank you for waiting for the microphone. And also thank you for your sharings. When I think to do performance testing for every commit or every pull request, it's coming to my mind as it's creating a CPU cost. If we don't try to reserve a CPU as always up, it's coming to my mind as we need to scale up or scale down when we are doing performance testing. And it's always increasing the cost.
Yeah.
Instead of increasing the cost, do you see any option to do CI/CD plus performance testing?
Yeah, that's a good question. Actually, within the context of the continuous performance testing, as I said, the load testing is the best practice to apply, right? Which means that there is a specific load which can be applied exactly the same system with the historical run. Which means that we can always use the same environment. So which means that the system shouldn't be scaled. We should be always using the same server. Under the same server and the same test environment, we should get the responses within the 95 confidence level. It is up to you. It might be 90 or the 99 confidence level as well. So which means that it can increase the cost, but it will be return value. Otherwise, if your strategy is to test the performance of the system, let's say in a classical way, maybe after a big release, so you cannot find the issue in your system. For example, there might be one commit in the code base, and it is causing a problem, but you cannot get it. And maybe your user can get it, and then it might be very expensive for you as well. It is similar to continuous testing. If maybe there is a bug, maybe that can be a functional bug, and then you cannot get it in your development process, but after the live with the user. So it is similar. So by applying the continuous performance testing, it cannot add as much as cost by you think, because you are always using the same continuous integration server, and then you can run the same test again and again for each commit, and then you can compare the response time with the historical data. I don't think that will be costly.
Okay.
Yeah,
Thank you.
Any question? Mm-hmm. Okay, I think I don't see any. Yeah. Thank you for joining. Thank you for having me here.
Sayın Mesut Güneş'e sunumu için çok teşekkür ediyoruz.